Let us start second chapter, alcohols. Okay. First we will discuss about nomenclature of alcohols. See, how many carbon atoms are present? One carbon is present. So meth. All are single bonds only, na? So ane. If OH is present, then ol. Meth plus ane plus ol, methanol. Right? And the second one, how many carbon atoms are present? 2 carbons are present. Ethanol. Let us take another one. See, this can be represented in the bond line form like this. So, molecular representation and bond line representation. Clear? So let us give the name for it. OH group is present at which position? Second position. So this is 2-propanol. 2-propanol. OH is at second position now. So 2-propanol. Clear? Right. Next. Give the numbering. 1, 2, 3, 4. 2-butanol. 2-butanol. Right. Let us give the name for this. Select the longest chain. This will be the longest chain. Give numbering 1, 2, 3. Right. At second position, methyl is there. So 2-methyl, 2-propanol. OH also at second position only now. So its name is 2-methyl, 2-propanol. 2-methyl, 2-propanol. Actually, common name also very important for this. This is also called as tertiary butyl alcohol. Tertiary butyl alcohol. Because this is tertiary butyl group. You know, this is tertiary butyl group. This unit is tertiary butyl. If we attach OH here, tertiary butyl alcohol. Tertiary butyl group. If we attach OH here, that is called tertiary butyl alcohol. Common name is very important. Right? Next. See, if we have double bond, then how to give the numbering for this? If we have double bond. See, if double bond is present and OH group is present, then priority goes to OH only, alcohol only. 1, 2, 3, 4. How to give the name? First write root word but, because 4 carbons are present. But, 3-ene, 2-ol. Right? Okay. Next. Cyclic. 6 carbons are present. Hex. So cyclohexanol. Cyclohexanol. Right? If other substituents are present, the numbering should start from the carbon which is attached to OH. Okay, because OH is main functional group. So numbering start from the carbon which is attached to OH. Like this. Okay, how to give the name? 4-bromo, 3-methyl, cyclohexanol. Clear? Let us see the classification of alcohol. How to classify the alcohols? See, alcohols are classified into three types: primary alcohol, secondary alcohol, and tertiary alcohol. 1 degree alcohol, primary; 2 degree alcohols, secondary alcohols; 3 degree alcohols, tertiary alcohol. See, based on the degree of the carbon which is attached to OH, based on the degree of the carbon which is attached to OH, we can classify the alcohols into 1 degree, 2 degree, and 3 degree. Let us see. Focus on this carbon, means carbon which is attached to OH. Right. I am taking only skeletal structure. This OH is attached to this carbon, right? Highlighted carbon. Now we have to see the degree of this highlighted carbon. This carbon is further attached to only one carbon, right? This one is attached to only one carbon. So this is a primary carbon, and OH is attached to primary carbon. So this is called as primary alcohol. If OH group, alcohol group is attached to primary carbon, the total compound is called as primary alcohol. 1 degree alcohol. Next, look at this middle one. Middle carbon is connected to two carbons, right side one carbon and left side one carbon. So middle carbon is 2 degree carbon, right? If OH is attached to 2 degree carbon, that is called as 2 degree alcohol. This is 2 degree alcohol. Clear? So based on the degree of the carbon which is attached to OH, we can classify the alcohols, right? Next, observe this highlighted carbon. This is connected to how many carbons? 1, 2, 3 carbons. This is 3 degree, right? If OH is attached to this 3 degree carbon, the entire compound is called as 3 degree alcohol. Clear? Right. Let us see some examples. What is its name? Ethanol. See, this carbon is connected to only one carbon on the left side. This is primary carbon, 1 degree carbon. So the total compound is called as 1 degree alcohol because OH is attached to 1 degree carbon. So this is primary alcohol, 1 degree. See this example. Observe the degree of the carbon which is attached to OH. Okay. This carbon is connected to right side one carbon and left side one carbon. So middle carbon is 2 degree and OH is attached to the 2 degree. So this is called as 2 degree alcohol. I given its name. What is its name? 2-propanol. Common name also called as isopropyl alcohol. 2-propanol. Common name is important, isopropyl alcohol. So what is the degree of isopropyl alcohol? Isopropyl alcohol comes under which degree? 2 degree. Very, very important. Isopropyl group means if one carbon is connected to two methyl groups, this is isopropyl group. See, both are same only, right? One carbon connected to two methyls. Middle carbon connected to two methyls. Isopropyl group. If we keep OH here, isopropyl alcohol, isopropyl group. If we attach OH, isopropyl alcohol. So isopropyl alcohol comes under which degree? 2 degree alcohol. Okay, right. Let us see this example. Now check the degree of the OH attached to carbon. This carbon is attached to OH. So see the degree of this carbon only, highlighted carbon. This carbon is connected to how many carbons? 1, 2, 3 carbons. So this is 3 degree carbon. So the total compound is 3 degree alcohol. I already given its IUPAC name and common name in the nomenclature. Right? 2-methyl 2-propanol. How to give the name? Once again see. At second position methyl is there. 2-methyl 2-propanol. also called as tertiary butyl alcohol. Clear? Right. Let us see some other examples of cyclic category. Some students will face some difficulty to identify the degree in the cyclic compounds, cyclic category. I'll tell you how to identify the degree of cyclic alcohols. What is the key point? We have to see the degree of the OH attached carbon. So highlight OH attached carbon. This is OH attached carbon. This is OH attached carbon. This is OH attached carbon. We have to see the degree of OH attached carbon, means that yellow dot, yellow carbon. Clear? Now I am representing surrounding carbons with different color. This is one carbon, this is one carbon. This is one carbon, this is one carbon. Here one carbon is present. This is one carbon. Clear? Right. Now OH attached carbon is connected to how many carbons? Right side one carbon, left side one carbon, two carbons. So this carbon is 2 degree carbon. So the compound is 2 degree alcohol because OH is attached to 2 degree carbon. Clear? Similarly, see, this carbon is connected to how many? 1, 2, 3. So the middle one is 3 degree carbon. So entire compound is called as 3 degree alcohol. 3 degree alcohol. This is very, very important, having idea about the degree. Okay. Next, here OH attached carbon is connected to only one carbon. So this is 1 degree. 1 degree alcohol. Okay. Right. That is about classification of alcohols. Okay. Let us see the preparation methods, preparations of alcohols. Preparations. Roman number 1 from preparation of alcohols from alkyl halides. Preparations from alkyl halides. See, in first chapter we already completed chemical properties of alkyl halides. Clear? Chemical property of alkyl halide is nothing but a preparation of alcohol. One reaction will come in the 2 lessons or 3 lessons also. Okay, look at this, all of you. This is chemical property of alkyl halide only now. Alkyl halide when treated with aqueous NaOH or KOH, or when it is treated with moist Ag2O, moist silver oxide, when it is treated with plain water, simple water, alcohol is obtained. Alcohol is formed. Very simple. When we add aqueous NaOH, the halogen will be removed and OH is added in the place of halogen. Already this reaction is over. Let us see one example. CH3, CH2, Cl, aqueous NaOH. So whenever you observe alkyl halide along with aqueous NaOH or aqueous KOH, what you have to do? Remove Cl and add OH. Okay, like this. Right. CH3, CH2, OH. Let us see some other example. Aqueous NaOH, or you can use moist Ag2O also. Moist Ag2O. Clear? Very simple. Alkyl halide when treated with aqueous NaOH or KOH or moist Ag2O, alcohol is formed. Very simple preparation method, first method, right? Let us see second preparation method. Second preparation method from alkenes. Preparation from alkenes. This is very, very important preparation method. See, by adding water to alkene, we can prepare alcohol. When we add water to alkene, we will get alcohol. But how to add water to alkene? How to add water to alkene? We have three different methods to add water to alkene. Observe carefully. Can you give its name? What is its name? 1, 2, 3, 4. At third position, methyl group is there. 3 methyl, 1 butene. 3 methyl, 1 butene is the name. Clear? Right. See, we have three different methods to add water to alkene. First method is direct addition of water in the presence of acidic medium. This is called acid hydrolysis or acidic hydrolysis. Addition of water in the presence of acid. This is first reagent. And the second reagent is HgOAc taken twice. Mercury acetate. Mercury to acetate. Water. And third one, lithium aluminum hydride or sodium borohydride. These three reagents add water to alkene, and these three reagents commonly called as OMDM. OMDM. I'll give you what is the meaning of OMDM. OMDM. When you observe OMDM on the arrow mark, you have to imagine these three reagents. OMDM is the set of these three reagents. OMDM stands for oxymercuration demercuration. Oxymercuration demercuration. What is the role of oxymercuration demercuration? This total set adds water molecule to alkene. Remember, whenever you observe these three reagents, add water molecule to alkene. But I will tell you what is the mechanism we have to follow during addition of water. Clear? Right. Next. Third one. First reagent is our. This is second reagent and third reagent. Third reagent is B2H6 diborane. In the presence of tetrahydrofuran. Tetrahydrofuran is the solvent, followed by oxidation. H2O is oxidizing agent in the presence of basic medium. Okay, this total reagent also used to add water to alkene. Okay, and this total reagent set of reagents combinedly called as hydroboration oxidation. Hydroboration oxidation. First of all, you have to remember what are the reagents to add water molecule to alkene. 1, 2 and 3. Okay, but we should follow the mechanisms. Each reagent follows a different mechanism. For example, if we take first one, acid hydrolysis, when you add H2O in the presence of acid, addition of water takes place according to Markovnikov's rule with rearrangement concept. I'll give you here. Look at this. Addition follows M rule, Markovnikov's rule with rearrangement with RA. I'll explain with mechanisms. Just I'm giving flow chart. Okay. Next, when we add OMDM to alkene, addition of water takes place according to Markovnikov rule, M rule only, but without rearrangement. This is with rearrangement now. This is without rearrangement. Addition follows Markovnikov's rule without rearrangement. See, with rearrangement and without rearrangement. I'll tell you what is rearrangement. Okay. Next, when we do hydroboration oxidation, addition follows anti-Markovnikov's rule. Anti-Markovnikov's rule. See the product. Addition follows AM rule, anti-Markovnikov's rule. Addition follows AM rule. AM rule stands for anti-Markovnikov's rule. Clear? Let us start the mechanism. Okay, with a brief explanation. Right? Okay. I'm taking the alkene. This can be taken in general molecular representation also. Both are same only now. One is bond line, one is normal representation, right? Okay. When we add water in the presence of acid, where OH will be added? At this place. Okay, let us see the mechanism. H2O dissociates into H plus OH minus. Okay, this H plus adds to alkene first. You can write it as a step 1. Step 1, addition of electrophile, or this is also called as formation of carbocation. Formation of step 1 is also called as formation of carbocation or addition of electrophile. H plus is electrophile only. Once look at this, I am shifting this pi bond. Here one pi bond is there now. Shifting this pi bond onto terminal carbon. Onto the terminal carbon. Then terminal carbon will get negative charge. We know already. If one atom will get bond, that will get a negative charge. And this carbon is losing the bond. So this will get positive charge. This middle carbon is losing the bond. Because bond is going towards terminal carbon will get negative charge. So H plus preferentially go to terminal carbon because terminal carbon is getting negative. H plus requires negative, like this. Okay. Next. CH3 CH positive and CH3. Clear? Here two hydrogens are there, one new hydrogen is coming, that's why I wrote CH3. And why this is getting positive charge? Because it is losing the bond. One pi bond is going towards terminal carbon. That's why this carbon will get positive because it is losing the bond. If one atom loses the bond, that will get positive charge, right? So carbocation formation takes place. This is which degree carbocation? 2 degree carbocation. And remember, in any reaction, if carbocation is formed, we have to check for the rearrangement. Okay, let us see. Step 1 is the formation of carbocation. Step 2 is the rearrangement. Rearrangement of carbocation. Take this carbocation as easily. I am writing one H down. Here hydrogen is there now. I am writing that hydrogen down. CH positive and a CH3. Okay. Now look at this. Highlight this bond. In this bond, how many electrons are present? two electrons are present. One electron belongs to carbon and one electron belongs to hydrogen, right? Now hydrogen is taking two electrons, two bonded electrons with itself and reaching the carbocation as H minus. Why we are writing H minus? Because hydrogen is taking its own electron and electron of carbon also. It is getting one extra electron. It is getting electron of carbon. That's why leaving as H minus. H minus. Here positive is there and H minus is coming. Positive negative neutralization. CH3 C CH3 positive charge. Okay. Here we'll get positive charge. Here CH2. Why we are getting CH2 here? Already CH is present and one hydrogen is coming. That's why CH2. Right? Now this is which degree? The middle carbon. Carbon with a positive is surrounded by how many carbons? 1, 2, 3. 1, 2, 3. So that's why it is 3 degree. 3 degree carbocation. This is 2 degree. Why we did like this? Why we shifted hydrogen? This is called rearrangement. Movement of atom or any species from one place to another place is called rearrangement. Why we did rearrangement? To get higher stability carbocation. Clear? That is the reason. So whenever carbocation is formed, do rearrangement. Do rearrangement. Clear? Right. Rearrangement step is over. Next. Once look at this. OH minus is formed now here. That OH minus attack the carbocation. Okay. Leads to the formation of alcohol. So required alcohol is formed or not? Clear? So when you add water in the presence of acid, you have to follow this mechanism. You should follow strictly. Okay, first you have to add H place. Okay, then check whether rearrangement is taking place or not. After that add OH minus. Clear? Right. So this is with the first reagent. H2O, H plus. Follow some rule with rearrangement. We did rearrangement or not? Right. Next, second one, OMDM. OMDM. See, here addition follows Markovnikov's rule without rearrangement. Without rearrangement, you no need to do any rearrangement. You can add water molecule according to Markovnikov's rule directly. Let us see. Mercury 2 acetate, HgOAc taken twice. Second one water, lithium, aluminium hydride. Right. This total set of reagents adds water molecule according to Markovnikov's rule. What is the Markovnikov's rule? Negative part. In water, what is negative part? H2O. What is positive part? H plus. H2O, water dissociates into H plus and OH minus. Clear? What is Markovnikov's rule? Negative part adds to carbon with less number of hydrogens. So this carbon is having only one hydrogen. This carbon is having two hydrogens. So negative part adds to carbon with less number of hydrogens. Got it? So we will get a CH3CH. Clear? With hydroboration oxidation means B2H6THF. B2H6THF followed by oxidation H2O to OH minus. When we use this reagent, we have to add water molecule according to anti-Markovnikov's rule. Okay. Anti-Markovnikov rule means negative part adds to carbon with a more number of hydrogens. Okay. See, B2H6 sometimes also represented as BH3 also. B2H6, BH3. Role is same. Addition of water takes place according to anti-Markovnikov's rule. Okay, let us see one more example. OM-DM, oxymercuration, demercuration. BH3, THF or B2H6, BH3 or B2H6. H2O2 followed by OH minus. Right. What is the role of OM-DM? Adds water molecule according to Markovnikov's rule. What is Markovnikov's rule? Negative part adds to carbon with less number of hydrogens or carbon with zero hydrogens. Zero hydrogens. See, look at this carbon. How many hydrogens are present on this carbon? I am giving two different colors. All right. At first dot, how many electrons are present? At first dot, look at this. At this dot, how many? Sorry, not electrons, hydrogens. How many hydrogens are present at this dot? See, this is one bond, right? This is one bond, right? This is one bond, and again one bond. Already this dot, this carbon is surrounded by 4 bonds. Valence is completed now. Already carbon valence is 4 and 4 bonds are present. So there is no hydrogen. There is no hydrogens. Here 0 hydrogens are present. Less hydrogens. 0. 0. Clear? And let us take this dot. 1 bond. Again 1 bond and 1 bond. Around this dot, how many bonds are present? 3 bonds are present. But carbon valence is 4. So you have to imagine one hydrogen there. One hydrogen. You have to imagine. Clear? So this is very small topic only, basic topic only. But if you do not have idea about the number of hydrogens on the carbon, then you won't get the answer. Clear? That's why I explained valency of carbon concept. Clear? Right. Coming to OM-DM. What is its role? It adds water molecule according to Markovnikov's rule. What is Markovnikov's rule? Negative part adds to carbon with less number or 0 number. Negative part of water is OH minus. So OH minus will add here. So you will get this product. This is already present. So OH will add here and H will add here. Water OH like this. OH according to Markovnikov's rule. And what is the role of this reagent? Adds water molecule according to anti-Markovnikov's. Anti-Markovnikov's means negative part adds to carbon with more number of hydrogens. Here hydrogen is there now. So OH. This is 3-degree alcohol and this is 2-degree alcohol. Okay? Right. Any doubt in this? Right. One more example. In alkyl halides chapter, I explained ring expansion concept. After following ring expansion, the arrangement, you will get this alcohol. Clear? What is the mechanism for this? What is step 1 in the mechanism? Formation of carbocation, right? First shift this bond towards terminal carbon. Here one carbon is present, CH2 is present, right? So that will get negative. So H plus goes towards that negative. Okay. Middle carbon will get positive charge because middle carbon is losing the bond now. Middle carbon is losing the bond. Here pi bond is there now, we are shifting that pi bond. Clear? So this is carbocation. Now I explained already about ring expansion. This is which member ring? 1, 2, 3, 4, 5. 5 member ring. How many carbons are present in this ring? 5. 5 member ring, try to convert into 6 member ring. 6 member ring. 5 member ring, try to convert into 6 member ring. 4 member ring, try to convert it to 5 member, like that, higher member. Right? The ring expansion takes place. One new phenomenon, ring expansion. Step 2 is the ring expansion. Ring expansion. Take this carbocation as easily. Right. What I am doing, I am taking one bond in pink color. This is pink color bond. Okay. Right. Now what I am doing, this yellow dot represents carbon atom. Let us consider this is yellow dot and this is pink bond, right? Now I am detaching the bond, removing the bond. This pink bond, I am removing the pink bond and attaching here. Okay, remove the bond. Now bond is in your hands, attach here. That yellow dot is losing the bond, clear? Because this is yellow dot, you are removing the bond. So this is losing the bond or not, yellow dot? Remember that point. After that, see how I am writing. This line as it is, okay, this line as it is, this line as it is, here as it is, and yellow dot I am putting, yellow carbon, okay. Next this line, this line, right? Now what about pink bond? Pink bond is detaching here and attaching to this carbocation. Like this, okay? And yellow dot will get which charge? Positive, because here yellow carbon is losing the bond or not? So that will get a positive charge. This is called as ring expansion. Why this is ring expansion? Count how many carbons are present here. 1, 2, 3, 4, 5, 6. In this cyclic structure, how many carbons are present? 6. 5 member ring converted to 6 member ring. Why? Due to stability reasons. Clear? Now let us draw this 6 member ring in the proper format. Okay, both are same only, 6 and 6 member only, but how to write this methyl group, how to write positive charge? To avoid confusion, give the numbering 1, 2, 3, 4, 5 and 6. Give numbering 1, 2, 3, 4, 5 and 6. At the first carbon, one methyl is there now, so write methyl. At second carbon, positive charge is present, positive charge. Clear? Both are same. We wrote in the proper format. Clear? Right. This is about ring expansion. And again you have to do another phenomenon, that is rearrangement. Why? Again, in some questions we have to do ring expansion as well as rearrangement also. Clear? This is which degree carbocation? This is which degree? 2 degree carbocation. 2 degree carbocation, try to convert it to 3 degree because of stability reasons. Clear? Next, rearrangement. Take this carbocation as easily. methyl group, and here positive. At this carbon, this white color dot, one hydrogen is present because this white dot is surrounded by how many bonds? 1, 2, 3. So you have to imagine one hydrogen there. This hydrogen will shift to give 3-degree carbocation. This will get positive. Why? Because here bond is going now. This carbon is losing the bond. 3-degree carbocation. Now OH minus will attack to give the final compound. Clear? That is about preparation methods of alcohols by using alkenes. Okay? Right.